Hello and welcome back to compiler programming. In this video, I'm going to continue our exploration of the executable. In particular, if we look carefully at how this stuff works, so we have this import directory where the executable specifies which functions out of each libraries it uses. And so here you can see the name of the library, and here is the name of the function. And the way this works is that, so there is this kind of location in the executable that will be mapped into memory when the executable is loaded, and at a particular offset, so this, you can see here, thunk RVA, so relative virtual address. So at this relative address, there will be a pointer loaded to this function. So essentially, when Windows loads executable, it will load this chunk of data, and then according to the specification, go through each entry in this table, in the IAT stands here for import address table. It goes through every entry in this table and try to find inside of this library matching function name and load the library in the process and replace this function name essentially with actual pointer. If it cannot find the right function name, then it will just blow up. I don't believe you can specify optional dependencies inside the executable, although maybe you can, but by default it will just blow up and say, oh, actually I couldn't load whatever. And if you think about it, and the way it works for us right now, when we try to use something like, I'm not sure if it's here, yeah. So let's take a look and compare with what we do when we call puts. So here we are actually cheating because we are not loading the library and we are not loading the function. We are just saying, oh, actually, just take address of the function that we happen to have inside of our C code. But if our generated code wants to call a function that is not part of the already part of our C executable, then we can't do it, which is, first of all, very limiting. And second of all, it's not matching what happens inside of the executables, which means when we start writing out executables, we'll have a problem because our code just does not expect this stuff to happen. Instead, it expects direct pointers to functions. So let's fix that. And even though in like GTID code, we could cut out this middleman and patch in the addresses directly, I think it will be easier if both in GTID form and later in executable form, we just have this kind of jump extra indirection layer for the imported functions to make it work the same way and just make it easier on ourselves. The first thing we'll need is, I guess we'll need to bring out value.h. I think that's the right file. I can close this thing. We don't actually need this. I just wanted to show you the details. And here is the tricky part. So we will need to introduce a new operand type that is going to be treated very specially when it is encoded. And this type is going to be something like external or import. I don't know. I think I like external more. And the idea is this operand type will specify from which library and which function or which symbol to load, because we could also load like any kind of data. It doesn't have to be function. As long as the library exports it, we can load it in. So this is why it's like not attached to function, right? It's just a general way to refer to where operand is located. And in reality, external is the same thing as rip relative, but external has slightly different semantics. So we'll see if we can merge these two, but for now, maybe we want a separate one. Actually, to see if we want to merge them, let's do client code first and try to change how we do our tests. Now, I will leave this test as is, and instead we need some function that would be callable from anywhere. We need a Windows function, preferably with a side effect, so we can test. But I guess one without side effect will also work. So I'm not sure what we can call. I guess MSDN. We could do exit process, but unfortunately exit process will kill our test suite. So like that's not a great thing to use for tests. We could do a get std handle and just use that. I mean, that's fine. It's a simple function. It just expects a dword or signed 32 bits. When you program on Windows, you have to get used with all of these weird types that they use, because handle is just a void star essentially. WinAPI is a marker that doesn't expand to anything, and then dword is like signed 32 bits, and in just says that it's a parameter that is passed to the function as opposed to an out parameter which will be written to. Anyhow, we can use that. So basically, I just want to have a function that will proxy to get std handle, and should be able to call let's call it imported function, and we want a function, so we don't need this stuff, I believe. Instead, we will use our C function value, and then we will modify it slightly. In fact, we will probably modify this whole routine later on, but for now it is fine. And so it returns a handle, which means it returns a void star, which is basically a 64 in our case. Get std handle, and then it expects an s. So I'm not sure that our parser even can handle this stuff. So let's see if this is something that we need to fix along the way. But let's just continue. So x64 get std handle, and it accepts s32 probably, yeah. Okay. So let's start with this stuff and just check if the parser can even handle this stuff. Let's run the tests. Okay, we need to close this stuff, otherwise it will complain about it. Okay, unsupported argument type. That's fine. Let's just fix the C function value. Here we have we parse C type. Okay. So let's add our types and say this is S8. Okay, let's do this. So int is S32, and then we can do with star and S64 to be S64. Okay. Let's see if that helps. Okay. Now we at least can parse this stuff, which is great. And we can continue with our test. So get std handle. It has operand, and the idea would be, so we need to say to the, so actually we probably could use rep relative addressing directly here. We might have to change it later on when we switch to actually writing active executable in USDY, but for now it is probably okay if we do that. So where is like, first let me mark this stuff as the bookmark, and then I want my rep relative addressing somewhere. Is it like this? Maybe it's another test suite. Yeah, okay. So this is also something to improve. Right now we don't really have an official way how to deal with, how to create a space for that, but we can deal with it later. Essentially what we want to do is say, okay, we will have this reserve this space the same way as it was reserved in the executable. And right now we're just gonna put stuff there. It doesn't matter what it actually is. So this is 8, and this is should be 64. And we probably, I will need to do this stuff. You might be unnecessary, but well, I guess it's required. I'm not sure about semantics here, but whatever. And now we have this stuff, and we need to create a value which will hold the pointer to our function. So descriptor will not change, but we can take this and use this as an operand. And that seems fine to me. Okay. If it works, it works. And now we need to figure out what to put in there. So the thing is that like I could just write out actual so instead of these God knows what, I could just put like so, and maybe that's what we will start with to make sure that the actual call works, but later we will replace it with something else, because this is exactly the same as what we are doing with puts, but we are just using rep relative addressing to figure out what is the target offset of the function, right? What are we calling? What address are we calling? Instead of having it as immediate, we have it as rep relative. But it will change in a moment. So here we say return, and I guess the only thing that we can really check is that it returns something that is not null to us. So that's about as much as I can figure out. So type will be void to 64, and let's call it, sorry, checker value. We have it here, we have it here, and call, we are calling get std handle. And actually this will be a problem. Let's call this stuff get std handle value. This is not required anymore. Okay, yeah. So we are calling it std handle value, and we are calling it with here I can just directly use this macro std input handle. But obviously, if you would do it in our code, we would need to define this constant, which is pretty straightforward to just do it. Okay, so let's see how we are. Check. So I think first of all I'm missing this stuff. Okay, that's good. This should be this, I guess. So this is fine, just need to cast this. Syntax error, yes. You're right. Value star differs in levels of indirection from dword. Yes, it does, because it should be value from S32 and then this. Okay, let's check this out. Okay, so this is quite interesting. It says that it cannot find move. This should be fine because RIP is just RM. So I guess we don't have move R64, RM64, which is kind of strange. Let me check that out. But maybe our call is doing something weird anyway, and we should take a look at it. There is so where is our call function overload push instruction. Yeah, so we are basically always calling through a register, which is fine. I mean, we could do better, but it shouldn't be a problem. Let's look at the move though. So it cannot find encoding from move R64 RIP plus XXX. That is very, very strange, because it should match this one, because a RIP relative is just a variation of RM64. Okay, let's figure out, let me recheck. Okay, so first of all, it should be like this, and maybe that's actually why, because it doesn't show that we are targeting 32-bit value. Let's try again. So now it is very unhappy about M64R32. That's interesting, to say the least. Let's open up the Visual Studio and see where we are having troubles. Okay. Start. Auto. Source not found. Okay. It's fine. Assert code instruction function. So it's return that it is unhappy with. Why is it R32 though? This is very interesting. Did I mess up the parsing? No, it's descriptor has 64. Okay, let's just look at what we have there. So I want to pause over here and look at my get std handle stuff. Okay, get std handle value, type function, returns operand type register. Yeah, so the return type is borked for some reason. C function return value for declaration. Okay. For declaration, ch. Not exactly certain what's happening there. Let me check something again. So I have returns, I have operand, and what is your descriptor? Okay, so the descriptor is correct, but the operand is not. Okay, yeah. So I don't have the right stuff here. It should be register for, what is this thing called? Value register for descriptor. This is what it's called. Value register for descriptor. It should be like this, and the do I use it? Register A. Okay. Cannot convert from value star to value. Okay. It can't build because this thing is running. Good. Let's check if we are any better. Cool. So we can call the function, we get something back at least. I probably could do something like this. I'm not sure if it's supposed to return the same handle or not, but we can check. And the actual is this. Yeah, it's fine. Believe me, you can cast it to handle. Okay, cool. So it actually does return the same handle if I call std input handle multiple times. Okay, so we have a good test here. We know that everything is working as it's supposed to be working. But as I said, the issue is that we are just relying on the C compiler to get those functions, and this is not viable long term. So instead, what we're gonna do is we're gonna call a function that is called DLL import, I believe. Load DLL. Load DLL. Load library A. Sounds good to me. Get proc address. Yeah, I think that's how we can do this. Using runtime dynamic linking. That sounds great. This is exactly what we want. Yep. Sounds good to me. So essentially the way it works is we say directly now, okay, please load this library. And then we try to get the address of the procedure. And for us, that would mean that we replace this hard-coded stuff with a call to this get proc address. Again, later on, this stuff for us will be handled by the executable loader, but the point was that we need to figure out how to do it ourselves for JIT code so we can call arbitrary library without loading it in the C process. Cool, so that's what we have. Maybe I should create a helper function, but for now I will do it just inline. So we do this. We say that it's H instance, right? Yeah. All of those fancy, weird types that Windows has. So you can just ignore the text macro. It's basically a macro that is there to deal with Unicode stuff, but just ignore it. And also load library is actually a macro that expands to A or W versions. I'm just ignoring Unicode stuff for now. So, but if you just copy paste this code, it also will work. Okay, so H instance kernel 32 DLL, and we could verify, but I'm pretty sure it is there. Again, the way you find it, just to show this again, if I go here and say get std handle, I can go down and here it says DLL kernel 32 DLL. So this is what I will use for loading here. I should assert that it was actually loaded. I will just use our test infrastructure for this for now. Later we'll need to figure out some kind of error mechanism for that. But errors are a whole topic in itself, so we can deal with it later. Okay, and then we say that this is going to be void star get a std handle from DLL is get proc address, right? So this is what is necessary. We say get proc address of kernel 32 and get std handle. And we could totally upgrade our code here to do this for us, but then we'll need to have some kind of annotation that will tell where to actually look up this function, because I honestly don't like the way it's done in C, where you just kind of say, I want to use this function, and then you shove a bunch of library definitions at the compiler, and compiler searches all of the library definitions for which DLL actually has this function. And if you have several modules that have the same function name, you're screwed, even though, as we will see from the executable format, and as you can see here, there is actually no limitations on functions with the same name if they live in different libraries. So anyhow, we have these get std handle from DLL, and if everything is fine, then this is what we should get. So now we, instead of relying again on the C library to load this for us and to get this address, we are using kernel 32 code directly to do this. And these functions, load library and get proc address, they actually, this probably should be get proc address A, I'm not sure. These functions are also defined in kernel 32. So if you look at get proc address, it's there. And as a side note, kernel 32 actually is loaded into a process regardless of whether you want it or not, because that's the thing that actually runs it. So yeah, the point is, like, even if we are outputting to an executable, what we could totally do is just basically hard code these two functions in our imports, and then import all the rest ourselves, and just completely ignore the whole part of executable format that deals with it. And maybe that would be sort of an interesting way to try it out, because then we don't need to worry about a lot of the stuff inside of the executable and all the import tables and patching and whatever. So maybe I'll try it out. It's an interesting idea. Anyhow, enough talking. Let's see if this works and how good we are. So something does not happen. No start, blah, 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 blah. It's really unhappy about the fact that I'm trying to convert a function pointer to void pointer, which is indeed not allowed. It's undefined behavior in C. What is wrong with you? Conflict with Windows type definitions and our type definitions, but once we convert all the types to what we expect them to be, everything is great. I think that will be it for today. We have a nice setup over here. Obviously, there is a lot of stuff to be cleaned up, but now we are not dependent on the C library or C compiler for loading. We can load anything dynamically as we want to, just by specifying the name and knowing the library where it is located. And we are one step closer to be ready to deal with actual executables on disk. With that, thank you very much for watching, and hopefully see you next time.